Okay, so today we're going to talk about manipulating data. I'll just start sharing my screen here and we can get started. Okay, close my little video screen. All right, so we're going to talk about manipulating data. So some things that we're going to talk about are subsetting data, meaning we're just going to pull out some subset of our data, of a larger data set. We're going to create some new variables, right? Maybe we want to look at totals of some columns, or we are going to create a BMI variable. We'll talk about that later. And then we're going to move on to what if we want to remove rows or columns or even both, right? How do we do that? And what are some things we need to keep watch for, right? If we're removing stuff, we don't want to sabotage our data set. And then we'll change gears a little bit. I threw it in there just for fun. So, and then I'll show you how to find exact probabilities for z-scores with R. So if we've got a z-score, you've probably been using either a z-table or the table C or t-table to find ranges for probabilities, or if you're using the z-table, then exact probabilities, but they're not even exact. So R can find our more exact probabilities for z-scores, so I'll show you how to do that. And then finally, I wanted to show you how to add emojis to our text. We know that's very important. And I'm pretty bummed that it's not working on PCs. So I'll walk you through that, but it seems to be working on Macs, but I haven't gotten to the bottom of why it's not working on PCs. So don't worry about it, but it is just a fun thing, so I'll walk you through it. So first, let's talk about the data that we're going to be using. So the data that we're going to be using is, ironically, a subset of a huge survey that's put out in the States, and it's from the Center for Disease Control and Prevention. And so we call it the CDC data set for us. Right, and so all we're going to do is we're going to use the source command to bring it in, right? And then we'll have lots of variables. So some of these variables are listed here, or all of them actually. So we've got things like general health, X or any, and then there's brief descriptions of each of the variables down below here. So general health, respondents were asked to evaluate their general health, responding either excellent, very good, good, fair, or poor, X or any. Have you exercised in the past month or no? Yes or no? Kind of a tough one, but and then health plan, right? Do they have some sort of health coverage? Smoke 100 is kind of a weird one. If they've smoked at least 100 cigarettes in their lifetime, it's a yes, and if not, then it's a no. Their height, their weight, even things like their desired weight, their age, and their gender are recorded. So those are the little variables that we'll be looking at, right? So like I said, we're talking about a subset of this huge data set that they collect. Okay, so first thing we're going to talk about is subsetting. Okay? I want to pull in this data set, so I'm going to copy this code, and I'm going to start a new R Markdown file. I'll call it lab3 work. Okay. I'm just going to work through all of these commands that are being introduced, right? Making sure that I know what's going on there, and then I'll be able to apply those in the On Your Own section, or you'll be able to apply them, rather, in the On Your Own section. So I'm just going to clear this out, make a nice clean worksheet. I'll start with a new R code chunk, so 3 backticks, curly brackets, lowercase r, and then close it up with 1, 2, 3 backticks. Okay, nice. So I can paste this in here, and then I'm going to run it. So you can either just copy from up here and paste it down here in the console, or the shortcut that I like is just Control Enter or Command Enter if you're on a Mac. So your cursor just has to be on the line that you want to run, and then Command Enter just pastes it down here. And now it's thinking. We know it's thinking because it's got this stop sign here. It's a pretty big data set, so we'll just give it a little bit of time before we have a look. Okay, so now we know it's done, one, because it's got this prompt here, so it's ready for a new command, and also because we have the CDC data showing up in our environment tab. So we know we have 20,000 observations of 9 variables, and we already talked about what these variables are, right? The gen health, the X or any, the health plan, etc. So here we've got a quick overview of the CDC data. So often we want to compare males and females, for example. We want to compare, in the On Your Own section, you're going to compare a younger group to an older group, right? And so to do that, you're going to use subsets. So you're going to break up your data set into 2 or more than 2 subsets. For example, if you want to break up your data into, so you just have a subset of males, and then you can make a subset of the females, right? And then you can compare the different heights or weights or whatever of the males and the females. So to get a handle on how subsets work, we can try these 2 commands here. So just copy those. So CDC gender, CDC $gender equals, and then in quotes M. So if we have a look at the gender column, right, it's a factor with 2 levels. One is M and one is F. So what we're saying is go into the CDC data set, go into the gender column, and anything equal to M satisfies this criteria, right? And so what it's going to do is it's going to give us a true if it sees an M and a false if it doesn't see an M, right? So it's even false if you have more than 2 categories. So if we run this, we get just a huge amount of true, false, right? So the first one was a male, so that's true. The second one must be female, so that's false, female, right? And then it just gives us trues when it finds someone that matches this criteria of having an M in the gender column. Same idea with the age, right? If we want to know, okay, well, tell me who's older than 30, so CDC age greater than 30. Again, it just goes through and goes into the CDC data, goes into the age, and just checks, is the age greater than 30? Greater than 30, greater than 30. And so from these true falses, we can generate subsets, right? Subsets are going to be only those values where it generates a true. So let's say we want to look at a subset where the gender is just the males. So what we're going to do is we're going to create this subset, and we're going to name it something else so that we can use it later on. We can name it whatever we want, but M data seems to make a lot of sense. We like short names, even though they quickly get out of hand, as you'll see in a little bit, but M data seems to work just fine, right? That's our male data. And M data is going to be a subset of, so in brackets, CDC. So go into the CDC data set, and wherever you see a gender, so then go into the gender column equal to male, right? Then that's going to be inside our subset. So if we run this, then it generates this M data here, where it looks the same as the CDC, right? It's just that it's only got 9,569 observations, but of all the same variables. And it's just going to be all the males. You can do the same thing for the females. I wouldn't recommend showing the whole data set like this. So if you just print M data, oops, it'll just print a couple hundred rows, and then it'll just stop and say, well, do you really want me to do this? Probably not, right? Especially if you have to print out your report, that would be a huge waste, right? If you wanted to show just give a feel of what M data looks like, you can use the head command instead. So the head of M data just gives us a quick couple of rows, I think 5 or 6 rows, and then that should give us a good idea of what M data looks like. So if that's something you're interested in, right, having a look at your new data set, then you can use the head command, or tail if you want. That'll show the last few rows. Doesn't matter. So we can make more sophisticated subsets. So let's say we want to look at a subset where we have males who are over 30 years old. Right? So now we're combining our conditions. So we can look at this M and over 30, copy that, and just kind of dissect what's going on here. So we've created this new data set, M and over 30, which again is a subset of CDC where the gender doesn't actually matter if you have CDC $gender or gender, because it already knows to go into the CDC. Just saw this inconsistency. Anyway, so where the gender is equal to M, double equals, and just using the ampersand, age is greater than 30. So you can usually just kind of work out what your conditions are verbally and then translate it into our code, right? So if I say, okay, you want to pull out the males who are over 30, well, that's the gender is equal to M and the age is over 30. A quick note about the double equals. So we have to have the double equals just because we're asking if it is equal to M, whereas a single equals would replace the gender column with just M's. That's not what we want, right? We want to keep males and females and pull out those with M's, right? And so that's why we have to have the double equals. On that note, if you did muck it up and just use one equals and it overwrites your whole gender column, that's no big deal, right? Because all you would have to do is just rerun this first source command where you're initially pulling in the CDC data set, and then you'd have it all fresh again. And then you can go back and change your code and rerun it, right? And so you can always start over, and that's why we like working with scripts and code like this, because then we can just reproduce whatever we were doing. So we can use the ampersand, or if we want to use the an or statement, M or over 30, so male or over 30. We use the subset command again, where the gender is male, or, which is just a vertical bar, or age over 30. This vertical bar is, I didn't know which slash it was over, so I had to Google it. And I found this pretty funny image. It's over this one, which is apparently a backslash because the little guy would be leaning backwards. But it's over your enter key. Okay, so if you go shift and then backslash, there's, I had to Google this too, there's what we call a pipe, I guess, and it's just a vertical bar. So that's how you get this little value here. And we just read that as or. There you go. Or is called a pipe, as this one is called an ampersand. And now you have a fun way of remembering if it's a forward slash or a backslash. Great. If you only learn one thing from this lab, I guess. So that's subsetting. And you can do combinations of things. You can do less than equal to, right? Age greater than or equal to 30. That works. Make that change if you want to. And you can just Google subsetting in R and it'll give you lots of the options. Okay. Next thing we're going to talk about is creating new variables. So often we want to work with variables that we have, but in some other form. So often it'll be like a total, or you want to generate the square of some values. So then we can create these new variables using the old variables. So as kind of an extreme example, well, not that extreme, but a big example compared to what you'll have to do in the problems later, is we're going to calculate the BMI, so the body mass index of each individual in our CDC data set. So BMI in general is the weight over the height squared times 703. And it kind of talks about why 703, but it doesn't matter. All we need is this formula for BMI. So we're going to copy that. Where we say, okay, BMI is going to be the CDC weight. So go into the CDC $ or CDC data set and pull out the weight, and then divide it by the height squared, and then multiply by 703. That's exactly what we had in this formula, right? So we're just translating it into our code. So if we run that, you'll notice that we get this, it does generate a BMI variable, right? But it's just on its own, floating on its own. And that's not very helpful. Usually we want to tack it on to the CDC data set so that we can use it and look at the BMI with their age, with their gender, with their weight, all those fun things. And so to do that, to attach it to the CDC data set, you're just going to do CDC $BMI. And what that does is it tells our, okay, go in and look at the CDC data set. Is there a BMI? So that's the first thing it's going to look at. Is there a BMI variable? No, there isn't. Okay, then it's going to generate it. So what's going to happen when we run this, which I'll do in a second here, is it's going to generate a 10th variable called BMI, and it's going to be added on at the end of the CDC data set. So, voila. Now we've got this BMI, which has the same values, right, as down here, but now it's attached to the CDC data set. So now we can actually reference CDC $BMI and use it with the other variables, which is way more helpful than just having it float on its own. Okay. Then we're going to talk about what if we want to remove rows or remove columns or both, right? We want to slice and dice our data set. Maybe there's some rows that are empty, right, or basically empty, or the data is clearly entered incorrectly or something like that. So what we want to do when we're removing anything is we want to be careful to make a new data set with those values removed. so that we aren't actually changing the CDC data set. CDC stays the same, right? We can add to it, but we're never going to take away from it. If we're taking away stuff, then we're going to save it as a new data set and call it something that describes what we removed. So looking at this first example, I'll talk you through it. Say we want to remove row 400. So last time we looked at how do we just look at a single row, right? So we said, okay, I want to go into the CDC data set and then square brackets, row, comma, column. That lets us kind of zoom in on different points in our data set. So square brackets, 400, comma, and then nothing, end square bracket, would show us just the 400th row. Right? Now if we want to remove it, we just put a minus in front, so minus 400. So to save it as a new data set, we're going to call it CDC no row 400. I couldn't think of anything shorter. Right? No row 400. That's what it is. But it's also from CDC. So then I'm saying it's going to be CDC where the 400th row is removed. So if we run this, CDC no row 400 has one less observation, but it has all 10 variables still there. And we could go in and make sure that it actually removed the 400th row, but with one observation missing, I'm going to go ahead and assume it removed the 400th row just like I asked it to. What if we want to remove a series of rows? So let's say we want to remove rows 200 to 300. Then we're going to call it something different, right? CDC no row 200 to 300. Nice and brief, right? Is CDC, but again, rows 200 and then the colon, you can read to or through, right? So 200 to 300 and then leaving all the columns alone just by having this empty space here. Okay. And so we can put the minus in front, so minus 200 to 300. That's going to remove rows 200 to 300 from the CDC data set. So if we run that, now we have CDC no row 200 to 300. Now we have a subset of CDC with 101 observations removed, right? 200 to 300, it's 101 observations. Cool. Same idea if we want to remove a column. We just alter the column instead. Looking at the CDC data set, if we want to remove the Gen Health column, we would use the -1 here in the column, and then the row would be empty. So now, CDC no Gen Health, sure enough, has only 9 variables, and the first Gen Health variable has been removed, just like we told it to. If you want to do a combination of this, we can say, okay, well, CDC no row 200 to 300 and no Gen Health for whatever reason, right? So I want to remove rows 200 to 300, but I also want to remove the first column. I can do that. We can just double check. So sure enough, it has the same number of observations as the CDC no row 200 to 300 and the same number of variables as the CDC no Gen Health. We can make sure that the Gen Health is missing, and it is. So we can manipulate it that way using the minus in our square brackets to pull out rows or columns or both. All right, so let's change gears a little bit. So if we want to find exact probabilities for z-scores with R, we can use the p-norm command. And in this little blurb here, I've shown you that there's actually two ways that we can use the p-norm command. And so it'll either take x comma mu comma sigma, right? So your values of x, mu, and sigma. Or if you just have a z-score that you want to use, then you can just use p-norm of that z-score, and it'll just know what to do depending on what it's getting. So for example, if you want to find the probability of an observation less than 72, if the mean is 60 and the standard deviation is 5.1, you can use this first p-norm command. So x is 72, mu is 60, and sigma is 5.1. So you can enter that, and it tells us that the probability is 0.9906872. What's important here is that it'll only give us the area or the probability to the left of the z-score, right? So this is the area to the left of 72. What if you want the area to the right of 72? That's just 1 minus the area to the left. So 1 minus the p-norm command gives us the area to the right. Same idea if you have a z-score that you've calculated by hand. Here I had to do it in R just so I had it. So what I've done here is I've calculated a z-score, 72, so x minus mu over sigma, that's our z-score, right? And so I've called it z-score equals 72 minus 60 over 5.1. And then I've done the p-norm command of z-score. So if I run z-score, it'll just save it down here as a z-score, and it's 2.3529411764, whatever. And so now, if I want to find the area to the left of that, I can do p-norm of z-score, and it'll give me the exact same area that I got before. Again, just the area to the left. Nice. Okay, now to my big disappointment, the emojis. So what you're going to have to do is you're going to have to first install the DevTools package. So keeping in mind that this definitely won't work on PCs, I'll probably have to come back. Actually, you know what? I'll do the emojis once I get it up and running, because I'm confident that I will be able to get it up and running. So that's all you need to know for manipulating data. And so on your own, just give you a quick run through here. You're going to make a new variable called wdiff, and you're going to attach it to CDC. wdiff is going to be the difference between the desired weight and the actual weight of each person. So just one minus the other, it doesn't matter the order. Right? And so question 2, if an observation of wdiff is 0, what does this mean about the person's weight and their desired weight? Right? What if it's positive? What if it's negative? Just thinking about our data. So you just have to tell me what's happening, right, with different values of wdiff. Third question, you're going to create 2 new data sets, one with ages 18 to 40. 18 is the minimum and 99 is the maximum. So really, you just want to find a data set or a subset of CDC where the age is less than or equal to 40. and then another subset of CDC where the age is greater than or equal to 41. And now you've got this younger data set and this older data set or subsets. And then I want you to look at the summary of the WDIF variable. So zooming in on the WDIF variable for each of these groups and tell me if there's any differences that you spot between the two, or any extreme differences that you spot between the two. Question 4, you're going to make a new data set with the X or any and the first 100 rows removed. So in one command line, right, you're going to remove, so just looking at the code that we just went through, that's going to be very similar to this here, right, where we want to remove the first 100 rows. Right? So rows 1 to 100. And you want to remove the X or any variable, which is your second column. For the 5th question, I like this question because it lets you kind of show off and get creative at the same time. So I want you to find the mean and the standard deviation of the weight variable, just in general for CDC, so not just the subsets, and determine what proportion of weights are within one standard deviation of the mean. And so we know that we're expecting about 68% of our data to be from the 68, 95, 99.7 rule. So 68% is where we're expecting our proportion to be that are within one standard deviation of the mean. Right? So I'm talking about the sample standard deviation and the sample mean. So it's not going to be exactly 68%, right? But it should be pretty close. And so I'm just curious to see what you come up with to try to answer this question. And I'm sure you'll get an A for effort. So question 6, what's the probability of an observation larger than 14 if the mean is 12 and the standard deviation is 1.2? So now you're going to use that p-norm command. Remember that the p-norm command only gives you the area to the left, and here we want the area to the right, of course. Ignore question 7, insert a fun emoji. It's not working, but I'll have to add something when I get it working. Anyways, so there you have it, folks. Manipulating data. All right.